All right, so here in section 4.2, we're going to be looking at trigonometric functions and specifically their relations with the unit circle. So what should you expect to get out of this lesson? We're going to talk about the 6 trigonometric functions in terms of the unit circle. We're going to evaluate those 6 trigonometric functions at different angles. Use basic trigonometric identities to evaluate trigonometric expressions. And finally, use even and odd properties of trigonometric functions to evaluate expressions. So what is the unit circle? So unit means 1. And so this circle is a circle with a radius of 1. And so if you wanted the equation for that, it would be x squared plus y squared is equal to 1. So anywhere on the circle, right, that the distance from the origin out to the edge is 1. So there's an infinite number of points that satisfy that equation, but there are really nice points that we use for trig functions. So recall that the formula for the arc length of a sector, which we did in the previous section, is S equal RT. If the radius for the unit circle is 1, then the arc length is just equal to T, which is the central angle. So the unit circle, the radian measure of the central angle, is equal to the length of the arc. The unit circle may be used to define the 6 trigonometric functions and describes their relationship with the x and y coordinates. So here we are defining the 6 trigonometric functions. So first off, those are sine, cosine, tangent. Those are the ones we're used to. And then their counterparts, cosecant, secant, and cotangent. The trigonometric functions, or sometimes called circular functions, is a coordinate or ratio of coordinates on the unit circle that serve as functions of the inscribed angle. So basically what that's saying is, if you look down here on the right of this chart, each of the trig functions can be related to something to do with the x or the y coordinates, or some combination of them. So the sine of some angle is just equal to the y coordinate, and the cosine of some angle is equal to the x coordinate. So if you look on the unit circle, right, if I were to just draw a point over to here, and I created a triangle out of that, a right triangle to be specific, where this coordinate is the x value, this is the y value, right? If this is x and this is y, then the sine of the angle we know is opposite, and the hypotenuse we know is 1, right? The radius. So it'd be y over 1, or just y. And then the cosine would be the adjacent side, x, divided by the radius, which is 1. So that's why it's just x. The tangent is also the ratio of sine to cosine. And because of that, it is just y divided by x. Then we have the cosecant, which is related directly to sine. So it's 1 over the sine, which is how you get 1 over y. Secant is related to cosine. So it's 1 over cosine, or 1 over x. And then finally, the cotangent, which is related to tangent. So it's 1 over tan, which would just give you the reciprocal of that guy, which is x over y. So those are all of our trig functions. Let's go ahead and apply the unit circle to those trig functions. So we have a point here on the unit circle corresponding to a real number t. Find the values of the 6 trig functions at t. So we know that sine of the angle t is just the y coordinate. And in this case, the y coordinate is 8/17. So that is sine of t. If we wanted the cosine of t, we know that that's just the x-coordinate. So that's going to be here, which is -15/17. And if you wanted, we could just make sure that this point does lie on the unit circle. We could square both of these numbers, add them together, and take the square root. So if you'd like to do that, go ahead. We have sine, cosine. We know that tangent of some angle t is the y-coordinate divided by the x-coordinate. So that's 8/17 all over -15/17. And we can simplify that because we can flip and multiply by the second fraction that we're dividing here. And that's nice because they're both over 17. And so when we flip and multiply, those cancel, and we get -8/15 for the tangent. Okay. Again, we could have just done sine divided by cosine, and that would have given us the same result. Okay. So we've got the first three. Now we need the cosecant. We know that cosecant is related to sine. It also is 1 over the y-coordinate. So that's 1 over 8/17. And if we flip and multiply, that's 17/8. Okay, 2 more to go. We need the secant. Secant's related to cosine, or it's 1 over x. So 1 over the x-coordinate, which is -15/17. And so that's -17/15. Okay. So we've got cosecant, secant. Last one is cotangent. And that's x over y. And we also know that it's 1 over the tan. So it's going to be the reciprocal of this fraction here. But let's just show it. So that'd be -15/17 all divided by 8/17. So it's -15/17 times 17/8. 17s cancel, and I get -15/8. Okay. Those are all of the trig functions corresponding to that angle t. So just block this off here. Okay. Let's go ahead and take care of this guy. See if we can make him right a little smaller so we can fit them all in. So here's another example. We want the sine, and we use a little bit better pen there. So I want the sine of t. We know that that's equal to y. So that's equal to square root of 2 over 2. Then I want the cosine of t. That's equal to the x-coordinate, which is -√2 over 2. Tangent, we can either do is y over x, or we could do sine over cosine. Same thing. It's square root of 2 over 2, all divided by -√2 over 2, which just gives me √2 over 2 times, I'm going to flip and multiply, -2 over √2. And that's nice because the √2's cancel. And then these 2's actually, right, just divide out and become 1. And after all that, we get -1. Okay. Sine is related to cosecant. And since cosecant is 1 over the sine, I'm just going to flip this fraction. It becomes the reciprocal. And in a lot of cases, we don't like to have radicals in the denominator, so we have to normalize. So we would multiply by √2 over 2. And the square root of something times the square root of something is that something. So we would get this. And so these 2's would cancel, and it would just be root 2. So that's a lot more clean. Then we want the secant of t. So secant is related to cosine. It's 1 over the cosine. And so it's the reciprocal of that. And again, we would normalize, right? So we don't like to have radicals in the denominator. Then we would have negative 2 root 2 over 2. And so we would get negative root 2 for that one. And then finally, the cotangent is 1 over the tan. So that would be 1 over negative 1 or negative 1. You could also do, for the cotan, you could do the x over the y, which was negative root 2 over 2, divided by root 2 over 2, or you'd flip and multiply, and you would still get negative 1 out of that. In these next few exercises, we're going to be looking directly at the unit circle. And here you see a unit circle that's been filled out with common angles. So 30, 45, 60, 90, right? And then continuing on by either increments of 15 or 30 degrees, all the way to 360. All of these have very well-defined values for x and y that are irrational in some cases, but they are nice values like root 2 over 2. So if we would like to find the sine or cosine or any trig function of any of these angles, then we can just look at the unit circle to get them. However, in some cases, the angles we're given are beyond 360 degrees. In those cases, as you see in the second bullet point there, it says to find a coterminal angle. So what we need to do is subtract 360 degrees from whatever value we have, or multiples of 360, until we can get to an angle between 0 and 360. So I'm actually going to share my screen, and I'm going to put the unit circle off to the side so that we can see it while we are working here. Okay, I'll just zoom in a little bit so hopefully you can still see the questions. So this says, find the exact value for each expression, rationalize the denominator. I think it says if required. Let me just scroll across here. Yeah, if necessary. All right, so sine of 45 degrees. So we need to go to the unit circle and find 45 degrees. It's right here. So we are looking at this coordinate. Sine, we know, is related to y. And so we just need the y coordinate. That's not so bad. Okay. Cosine of 4 pi over 3. Well, sine and cosine are on the unit circle. And by the way, let me just write this because it wasn't written explicitly earlier. So any point on the circle, right, is basically cosine of the angle, sine of the angle. So we did say cosine's related to x, sine related to y, but it's a little bit better if we write it this way. So we're looking for cosine of 4 pi over 3. So we just need to locate 4 pi over 3. Well, as I go around, I see pi over 3, 2 pi over 3. Here I land on 4 pi over 3. And these are the values of x and y, or the cosine and the sine. So the cosine of 4 pi over 3 looks to be the x value, which is negative 1/2. All right, let's continue. Tangent of 11 pi over 6. So again, we just need to locate that point on the unit circle. It appears that 11 pi over 6, let me just get rid of these, is right here. And those are my sine and cosine. Now, they asked me for the tangent. So tangent, I know, is the y over the x. So I just need my y coordinate, which is minus 1/2, over the x coordinate, which is √3 over 2. I'm going to flip and multiply. Cancel what I can, so the 2's will cancel. And then I now get negative 1 over √3. It did say we should go ahead and normalize. So I'm going to multiply by √3 over √3. And that's going to give me negative √3 over 3. And that's the answer that I want. All right, this one asks for the cosecant of 675. So cosecant, right, we have to know what does that equal. Well, cosecant is related to the sine. And it's 1 over the sine. And we know that sine is equal to the y coordinate. So this should be 1 over the y. And so I need to find 675 degrees on my chart. So now I'm looking on the inner part here where they have the degrees. But remember, it only goes up to 360. So how do I find 675? Well, I just need to take 675 and subtract 360. Now, of course, if this doesn't get me a number between 0 and 360, I have to subtract another 360. But if I do this, right, 675 minus 360 is 315. So what does that mean? What it really means is 675 means I go around the circle once, and then another 315 degrees. So that would be the total angle. And so I can just use 315 degrees to figure out what is the cosecant of 675 because they land me in the same position. So cosecant of 675 is the same thing as the cosecant of 315. And according to this, the y coordinate of 315 degrees. All right, let's go ahead and make sure I look at the right thing here. We're looking at this guy. The y coordinate's negative √2 over 2. So this is 1 over negative √2 over 2. Then if I flip and multiply, then this is 1 times negative 2 over √2. And then I need to normalize. So I need to multiply by √2 over 2. Or sorry, √2 over √2. That gives me negative 2 √2 over 2. All those 2's there, right? Going crazy on 2's. And I get negative √2. So all that is to get me to negative √2. Right? They can do this to us in radians as well. So here we have the cotan of negative 13 pi. So the cotangent, right, is related to tangent. So cotangent of negative 13 pi is equal to 1 over the tangent of negative 13 pi. Or it's 1 over the y over x coordinate, or it's x over y. So I don't really need to know what the tangent is. I just need to know the x and the y coordinates. So I need to figure out where is negative 13 pi. Well, that's actually pretty easy, right? Because this is 0. This is pi. This would then be 2 pi. So it just keeps kicking me back and forth, right? Another way I can do that, instead of just counting going around 13, right, is we know to go around the circle one time. That is 2 pi. So I can subtract, or in this case, I can add multiples of 2 pi. So negative 13 pi plus, and let's do 6 times 2 pi. So that's going to be negative 13 pi plus 12 pi, which is negative pi. So I would like to get positive pi. I could still do that. That's pretty easy, right? If this is positive pi, then this is negative pi. But let's go ahead and get a positive one. So let's do, instead of 6, let's do 7. And that'll give us 14 pi, and that'll give us a positive pi, which still gets us right here. So what is the cotangent of negative 13 pi? Well, the cotangent, negative 13 pi is the same as the answer to the cotangent of pi, which is the x over y coordinate. The x coordinate is negative 1. Uh-oh, the y coordinate 0. I'm dividing by 0. That's not good. What does that tell me? Well, if I divide by 0, right, before we get to calculus, the best we can say is this is undefined. And that happens. All right, continuing on, we are now trying to find all 6 trig functions for each of the angles given. So this first one is 3 pi over 4, and we can very easily locate that here on the unit circle. So I can do the sine and cosine and tangent very rapidly, right? Sine of 3 pi over 4. Sine is the y coordinate, so that's root 2 over 2. Cosine of 3 pi over 4 is the x part, so that's negative root 2 over 2. And then tangent is the y coordinate, root 2 over 2, divided by the x, which is negative root 2 over 2. So I'm going to flip and multiply. Sorry, this would be that and negative. There we go. And all of this is going to cancel out. Right, root 2 divided by root 2 is 1. 2 divided by 2 is 1. We're left with a negative, so it's negative 1. Then I need the cosecant of 3 pi over 4. Cosecant is 1 over the y coordinate. So that means that I am doing 1 divided by root 2 over 2. And that gives me 2 over root 2, which I don't like. So I need to multiply by root 2 over 2 to rationalize. And root 2 times root 2 is 2. All right, we've done this so many times now. This just becomes root 2. Then I need to do still the secant of 3 pi over 4. That's 1 over the x. That's 1 divided by negative root 2 over 2. You could probably guess where this is going to go, right? I flip and multiply by root 2 over root 2. Then that's negative 2 root 2 over 2. And finally, we get negative root 2. And last but not least, we need the cotangent. So I'm going to come up here where I have some space. So cotan of 3 pi over 4 is the x over the y. So that's negative root 2 over 2 divided by root 2 over 2. Flip and multiply. And we get negative 1. All right. So not much there. We can read at least the sine and cosine directly. The tangent's just the division of the two. And then cosecant, secant, and cotan, you just have to remember their relationships with x and y, or their relationships to sine, cosine, and tangent. The next one is 3 pi over 2. So do we see that on our unit circle? Absolutely we do. That one's actually a really nice one. That happens at 270 degrees. Now this one might give us some interesting results as well. So we need the sine of 3 pi over 2. The sine of 3 pi over 2 is the y coordinate, so that's negative 1. Cosine is going to be the x coordinate, that's 0. Tangent is the y coordinate divided by the x coordinate, which we've already seen. So negative 1 divided by 0 is going to give us undefined, right? Because we can't divide by 0. Then we have cosecant, which is 1 over the y. So that's 1 over negative 1 or negative 1. Secant, which is 1 over x. That's 1 over 0. That's also undefined. And then finally, we have cotan, which is the x over the y. So that one's just 0. So we fulfilled all of the 6 main trig functions, and we can continue on to another problem. So this one's interesting because it's a negative angle. Obviously, the unit circle doesn't have negative angles directly on it. To go ahead and add 2 pi to this. So let's call it a reference, is 2 pi minus 4 pi over 3. And so I need to get a common denominator. To do that, I would need to multiply by 3 over 3. And that's going to give me 6 pi minus 4 pi all over 3. And so that's going to be 2 pi over 3. So another way you could look at that, if you didn't want to do the 2 pi added to the angle, right? To get to 4 pi over 3 over here, we have to go at least 180 and then another 60, right? So what if I did that in the negative direction? Well, I would go 180 and then another 60. So look where that gets me, right? 2 pi over 3. All right, so once we have the angle that we can use instead of the one that's there, we know where to look on the unit circle. We are looking currently here. And so we just need to use that now to calculate all of the pieces. So sine of negative 4 pi over 3 is equal to root 3 over 2, right? The y component. The cosine of negative 4 pi over 3 is equal to the x component. The tangent of negative 4 pi over 3 is y over x. So that's root 3 over 2 divided by negative 1/2. Of course, we have to flip and multiply. The 2's cancel, and I get negative root 3 for that. Then I want to do cosecant. So that's going to be 1 over the y component Again, flip and multiply. So we have 2 over root 3, but we have to rationalize, so multiply by root 3 over root 3. And we get 2 root 3 over 3. All right, secant. Not as bad because it's 1 over the x. So flip and multiply yet again. And then finally, the cotan. So that is x over y. I'm sorry, root 3 over 2. And as always, flip and multiply. 2's cancel. I get -1 over root 3. Then multiply by root 3 over root 3. And we get -root 3 over 3. So those would be all of the corresponding trig functions for -4 pi over 3. So I think we have one more example here. This one's 17 pi over 6. So that's not a negative angle. So this time we're going to be subtracting amounts of 2 pi to get our angle that we can use. So I'm going to do 17 pi over 6, and I want to subtract. Let's do so 2 pi in terms of sixths, right, is going to be 12 pi. And so if I subtract that from it, I get 5 pi over 6. And that is an angle that should be on my unit circle. It's right here. So I can go ahead and start doing my trig functions. So sine is equal to the y component. So that's 1/2. Cosine is equal to the x component minus root 3 over 2. Tangent is the y over the x. And I'm just going to go ahead and do the flipping and multiplying without saying it every single time at this point, because we've done it so many times that I think you understand what we have to do to get something rationalized. All right, then I need still the cosecant. The secant. And the cotangent. Oops, 17 pi over 6. Oop. I'm so used to the eraser being so far over. I keep going to the other page and doing it. All right, so cosecant of 17 pi over 6, that's 1 over the y. So that's 1 over 1/2, which is just 2. Secant is 1 over the x. So we get that. And then the cotan is x over y. So if we flip and multiply, we get -root 3 out of that. So that would be all of those for 17 pi over 6.